Good morning, friends. We are going to continue our discussion on factoring, but today we're going to factor when the lead coefficient is not 1. In other words, when there is a number in front of the x squared term. So if we look at this first problem, we notice, first of all, that there is not a greatest common factor. 2, 15, and 18 do not share anything in common other than the number 1. So what we are going to do is we're going to have to come up with the two factors that multiply together, that after we multiply them together, we would end up with 2x squared minus 15x plus 18. So we have to think about what those are. And that's a little bit more challenging because of this number that's in front of the x squared, because of that number 2, because there is a number in front of x squared that is not 1. So what we are going to do is we are going to write 2x squared, a little bit larger marker there. I'm going to write 2x squared. I'm going to leave a space and leave another space and then write plus 18. And then I'm going to come over here and I'm going to make this x, which I think it was maybe Miss Pinkston that went through this with you yesterday, but I don't really remember who it was. But anyway, so we're going to take this number 2 and this number 18, positive 18, and we're going to multiply them together. And 2 times 18 is 36. So we're going to put 36 right here. And we're going to take this number that is in the middle, which would be b, negative 15, and we're going to put it right here. And we are going to ask ourselves, we are going to say to ourselves, what factors of 36 will add to negative 15. And then we think about all the factors of 36. For instance, 1 times 36, or 2 times 18, or 3 times 12. Ooh, winner, winner, chicken dinner, that's going to be it. Or 4 times 9, or 6 times 6. And we realize that if we have 3 times 12, and we multiply 3 times 12 together, we get 36. And if we add 3 and 12 together, we get 15. But, oh, we want a negative 15. So if we have a negative 3 and a negative 12, we are going to get negative 15. In other words, if I were to take these two numbers and multiply them together, they multiply to 36. And if they're both negative, they add to negative 15. So those are the ones we want. So now that I know those are the ones we want, I'm going to take the negative 3x and put it right here. And I'm going to take the negative 12x and put it right here. So now I have this, and that is called splitting the middle term. And it is called splitting the middle term because if I were to take these two terms and combine them, they would give me this term right here. Probably should have done that with green ink. If I would have taken these two terms right here in the middle and join them together, they give me this term. So that's called splitting the middle term. In other words, the negative 15 could be written as negative 3 and negative 12. Okay, so now that I've done that, now I need to see I have 4 pieces. I have 1, 2, 3, 4 pieces. So there are 4 terms to this quadratic now. So now that I have 4 terms, I'm going to take them and I'm going to think about them in pairs. I'm going to think about them in pairs. I'm going to think about this pair, and I'm going to think about this pair. And so when I look at the very first pair, I notice that 2x squared and negative 3x have a greatest common factor of x. So when I divide x out of each one of these, I am going to be left with 2x minus 3. And then if I look at the next pair, I have a negative 12x and a positive 18. They both have a negative 6. And if you're thinking, Mrs. Leonard, why did you take a negative 6 instead of just a 6? You always want to take the sign of the leader. You always want to take the sign in front of the first term. Well, the first term is negative 12, so I'm going to take the sign, the negative. So if I divide those both by negative 6, then that is going to leave me with 2x minus 3. So now, oh, look at this. This is insane. Check this out. Notice what happens now. What happens now is this parenthesis and this parenthesis are the exact same parenthesis. So in other words, that's now the greatest common factor. So what we have in common now is a parenthesis of 2x minus 3. And then in the next parenthesis, what we have left is x minus 6. In other words, when I pull out the one parenthesis, what remains is x minus 6. And so remember what I said I wanted to do? I said what I wanted to do was I wanted to figure out what factors would get me what I started with. So let's just see if I'm right. We're going to say this is the answer. Whoops, a little too much there. Shouldn't have touched that. I'm going to say this is the answer. If that's the answer, and I distribute back, 2x times x is 2x to the second power. 2x times negative 6 is negative 6x. Negative 3 times x is negative 3x. Uh-oh, did I mess up? And negative, no, I did. Yes, I did. Something's wrong. What did I do wrong? Six, 7, 8, 9. What's wrong? Damn. Oh, no. I didn't do anything wrong. I just did something wrong on my check. Let's back this up. Right here. Okay. 2x times negative 6 is negative 12x. There we go. And negative 3 times negative 6 is positive 18. And then when I combine like terms, I get 2x squared minus 15x plus 18. So voila. This is our answer right here. That is our answer. This is simply the check. All right, let's see if we can do this one a little more cleanly. A little more cleanly. Okay, so as soon as I recognize that I have a number in front, that is called a lead coefficient, not 1. As soon as I recognize I have a number in front, and by the way, 5 and 22 and negative 48 have nothing in common. Nothing whatsoever. As soon as I recognize that, what I'm going to do is I am going to write 5x squared minus 48. And then over here, in my x, I am going to take whatever, just want to use the same color as pink. I'm going to take 5 and multiply it by negative 48. And 5 times negative 48 is going to be a negative number. And 5 times 50 would be 250. So how about 240? 240. I believe it's 240. And then the number in the middle, the value of b, is 22. So I'm going to ask myself, what factors of negative 240 will add to be positive 22? Okay. That's what I'm looking for. And so I'm going to think of the factors of negative 240. And you could start making a list. Oh my goodness, what a list you could make. You could say 1 and 240, and you could say 2 and 120, and 3 and 80, and 4 and 60, and 5. First of all, is 48 times 5 really 240? Wouldn't that be terrible if it wasn't? Let's see. Times 5. Yeah, okay, good. Whoops, hello. Just checking my mental math ability there. And 5, 240, that'd be 48. And then does 6 go in there? Oh yeah, 6 goes in there 40 times. 7 doesn't, but 8 does. 8 goes in there 30 times. Does 9? I don't think so. Does 10? 10 goes in there. 10 goes in there 24 times. Does 11? I don't think so. Does 12? Yeah, 12 goes in there 20 times. Does 13? No. Does 14? No. Does 15? I don't know. Yeah, 15 has to because 3 and 5 do. 15 goes in there. 15 goes in there once. That'd be 15. That'd be 90. So that'd be like 16 times, I think. 15 times 16. Yeah. Oh, and that would be it. If you don't want to make that list, watch this. This is really cool, guys. If you don't want to make this list, grab your graphing calculator, go to y equals, type in negative 240 divided by x, and then look at your table. There's the list I just made. 1, 240, 2, 120, 380, 460, 548, 640, 830, 10, negative 24. For some reason it's stuck. Okay, but there's your list. If you know, and I know that when you guys were in integrated algebra 2, they gave you a factor sheet, or maybe that was integrated algebra 1. I don't know. They gave you some factor sheet. Anyway, we want to figure out, and because this is a negative 240, because this was a negative 48, and this is a negative 240, I want their difference. So what factors of negative 240 will add to be 22? I really want their difference. I want their difference to be positive 22. So what I mean by that, friends, is the difference of these numbers is 239 if I subtract them. The difference of these two numbers is 118 if I subtract them. The difference between these numbers is 77. 80 minus 3 is 77. The difference of these numbers is 56. These numbers, gosh, your brain is terrible. 60 minus 4 is 56. The difference between 5 and 48 is 43. The difference between 40 and 6 is 34. The difference between 30 and... Woo! Winner, chicken dinner! We got it right here, my friends. The difference here is 22. The difference there is 22. So, the difference is 22. So, I want 30 and 8, and I need the 8 to be negative. I need the 8 to be negative because if I multiply these together, I get negative 240. But if I add them together, I get positive 22. So that's what I want. I want the 30 and the negative 8. So winner, chicken dinner, 30 and negative 8. So I'm going to go plus 30x and minus 8x. And it doesn't matter who you put where. If you want to do the negative 8 and the 30 the other way around, you certainly can. All right, so So those are our two middles. In other words, my friends, if I were to take these two numbers right here, 30 minus 8, and combine them, I would get 22x. All right? Okay. Excellent. So now, here's what we're going to do. We're going to look at this pair of numbers, and we're going to look at this pair of numbers, and we're going to say, what is the greatest common factor? What is the greatest common factor of 5x squared and 30x? Well, 5x is. We can take 5x and divide it from there, and we can take 5x and divide it from there, and that's going to give us x plus 6. And then what are the greatest common factors of negative 8 and negative 48? Well, negative 8. And so if I divide negative 8 out of each of those, I get negative 8, parenthesis, x plus 6. And then what do I notice? What do I notice? I notice that this parenthesis and this parenthesis are identical. So the new greatest common factor is x plus 6. They both have x plus 6 in common. And when you remove or divide out x plus 6, you are left with 5x minus 8. Boom, baby. And that is the factored form. By the way, I just want to show you that it doesn't matter. So if we go back to 5x squared, and we put the negative 8x here, and we put the positive 30x here, and we put the negative 48 here, I just want to show you that it doesn't matter their order, okay? So now this is our pair, and this is our pair, okay? Then you say 5x squared and 8x only have x in common. And so if we pull an x out of here and divide an x out of here, we are left with 5x minus 8. And what do 30 and 48 have in common? 30 and 48 have 6 in common. So if I divide 6 out of there, I'm left with 5x minus 8. And now the greatest common factor is 5x minus 8. So when I pull 5x minus 8 out, when I pull out the greatest common factor of 5x minus 8, what I have remaining is an x plus 6. You will notice that those are the same thing. This set of factors and this set of factors is the same set of factors, and in multiplication order doesn't matter, so it doesn't matter who's first. Okay? Super cool? Fabuloso. Okay, so let's come here. There is no greatest common factor. 3, negative 19, and negative 40 have nothing in common other than the number 1. So the greatest common factor is 1, so we don't even worry about that. There is a number in front. So as soon as we notice there is a leading coefficient, we're going to write 3x squared minus 40. And then over here, we're going to take that 3 times negative 40. And that 3 times negative 40, this 3 times this negative 40 is going to give us negative 120. The middle term, the linear term, the term with the b in it, is negative 19. Okay, so I am looking for, stop moving around, I'm looking for factors of negative 120 whose sum is negative 19. And because it's a negative number, I need their difference, really. So if I think about all the factors of 120, so that's 1 and 120, that's 2 and 60, that's 3 and 40, that's 4 and 30, that's 5 and something, let's see, into 24, that's 6 and 20, 7 doesn't go, 8 goes because 4 and 2 go, so 8 goes 15 times, 9, I think 9 will go, 9 doesn't go, 120 divided by 9, nope, that doesn't work, 9 doesn't go, 10 goes 12 times, and 11 doesn't go. So those are our factors, and we want their difference to be 19. And by difference to be 19, I mean we want to subtract them. So if we take 120 minus 1, we get 119, and 60 minus 2 is 58, And 40 minus 3 is 37. And 30 minus 4 is 26. And 24 minus... Oh, winner, 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 winner. It would have to be a negative 24 and a positive 5 to get us negative 19. Okay, so we decided the numbers are 5 and negative 24. 5 and negative 24. So we're going to go plus 5x minus 24x. And then we're going to look at, now that we have 4 terms, 1 term, 2 terms, 3 terms, 4 terms, now that we have 4 terms, we're going to mark them off in pairs. So here's a pair of terms. Here is a pair of terms. These first 2 terms only have x in common. So when we divide out x, we're left with 3x plus 5. The next set of terms has a negative 4. I think they have negative 8. Negative 8. They have negative 8 in common. They have negative 4 in common, but we want to go as big as we can get. Negative 8. Negative 24x divided by negative 8. Oh, we want to pull out the negative 8. Hello. Is 3x plus 5. Marvelous, darling. Simply marvelous. Now, this and this give us, dun, 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 a greatest common factor of 3x plus 5. Remaining is x minus 8. So there we go. Again, let me demonstrate to you that it does not matter if you put the negative 24x first and the positive 5x second. It does not matter. So what matters is what you think is easiest. So then you look at these two and you look at these two. I see people like this better because they don't like a leading coefficient of 1. These have, what do they have? They share 3x. They both have a 3x. So the greatest common factor is 3x, and that leaves them with x minus 8. The greatest common factor of 5x and 40 is 5. So 5 is the greatest common factor, leaving you with x minus 8. And then, voila, they both have in them, as a greatest common factor, x minus 8. And so if x minus 8 is the greatest common factor, you factor it out, and that leaves you with 3x plus 5. And remember, the whole idea here, friends, is that we get back what we started with. So if we take this times this, we get 3x squared. If we take this times this, we get 5x. If we take this times this, we get negative 24x. And if we take this times this, we get negative 40. And then if we add these friends together, we get 3x squared minus 19x minus 40, which, winner, winner, chicken dinner, is the question. Awesome. Okay, so over here, we have no greatest common factor. We have a leading coefficient that is not 1. So we're going to write 12x squared minus 2. We are going to say that 12 times negative 2 is negative 24. We are going to say the linear term, the term in the middle, is positive 5. We are asking ourselves, what are the factors of negative 24 that add? Okay, we're just making up letters now, Mrs. Leonard. It's like you're, okay. That add to 5. So we got 1 and 24, 2 and 12, 3 and 8. Whoop! There it is. We do not need to go any further. We do not need to go any further. If we take 8 minus 3, if we take 8 minus 3, we get, whoops, yep, we get 5. So we want negative 3 and 8. So we're going to go minus 3x and 8x. And then we're going to do this and this, break them up into pairs. And we are going to say these have a 3x in common. These have a 2 in common. So 3x gives us a 4x minus 1. And plus 2 gives us a 4x minus 1. Our greatest common factor is now the parenthesis. And so if our greatest common factor is now the parenthesis, 4x minus 1, what remains is 3x plus 2. Boom, baby! And that's it. That is it for the video. Is that it? Good golly, Wally, there's so many more. Let's do one of these. Let's do this one. Okay. So first of all, friends, I'm going to notice that this and this and this are all divisible by 4. So my answer is going to have a 4 in it. 16x squared divided by 4 is 4x squared. 60x divided by 4 is 15x. And 54 divided by 4 is not doable. Darn it. Okay, let's back up. Let's not do 4 then. Let's do 2. Sorry. My brain was not engaged. Try again. They have 2 in common. They have 2 in common, so we're going to have 2 in our answer. 16 divided by 2 is 8x squared. 60 divided by 2 is 30x. And 54 divided by 2 is 27. Awesome. Then I'm going to go 8x squared minus 27. Boom. Boom. I don't know what 8 times 27 is, so you know what I'm going to do? I'm going to go 8 times negative 27. And that would be this number times this number. Multiply those bad babies together. I could multiply them together, but I don't want to. And then I'm looking for 30. 8 times negative 27, and I'm looking for 30. 8 times negative 27, and I'm looking for 30. Oh, this thing froze. Clear. 8 times negative 27 divided by x. Oh, it's going to freeze. I'm going to have to, there we go. And I'm looking for 30. So, 216, by the way, that number is 216. I'm looking for 30. Let's see. Oh, right there. 6 and negative 36. 6 and negative 36. 6 and negative 36. So 6 and negative 36. How about negative 6 and positive 36? Yep. And what did we say it was? Negative 216? Negative 216. There you go. Negative 6 times 36. Multiply to negative 216. Add to positive 30. So we're going to go negative 6x. Whoops, wrong color. Negative 6x and 36x. So friends, the only thing here was we had to pull out a greatest common factor first. So these have a 2x in common. These have a 9 in common. So we're going to go greatest common factor is 2x, leaving us with 4x minus 3. Greatest common factor is 9, leaving us with 4x minus 3. Greatest common factor is 4x minus 3, leaving us with 2x plus 9. So here's the deal. If we go 4x minus 3 and 2x plus 9, that's our answer. That is our answer. Because this 2 has to still be there. If we want to check our work, 4x times 2x is 8x squared. 4x times 9 is 36x. Negative 3x times 2 is negative 6x. Negative 3 times 9 is negative 27. That gives us 8x squared plus 30x minus 27. All has to be doubled. It all has to be doubled, and if we double it, 2 times 8 is 16x squared. 2 times 30 is 60x. And 2 times negative 27 is negative 54. That was quadratic that we had to start with. So this right here is our answer. All right, my friends, that is it. Have a great one. This video is already way too long.